historically, if you think of an oil and gas development, you have seismic, you have well tests, you have well logs, you have all these things. If you're outside of one of those oil and gas producing areas, what's kind of what is the source of information? Are you having to go out and do your own testing and prospecting of areas? Or is there government entities, or is there certain testing you could do at the surface level to determine what to expect subsurface? How's that process of prospecting work?
So there's a lot of data readily available for many parts of the country. So several universities and institutions have looked at temperature gradients in the subsurface across the U.S. And so there's a lot of just open data we can use. There's a lot of university data that we can use as well. Project Interspace is a big geothermal group that's really trying to drive and help improve the visibility, the viability, and the growth of geothermal.
Like
They
USGS,
operate.
the USGS involved? Are there any government? Is there government support for programs that are doing some of this testing to open up viable areas on behalf of industry? Is there anything like that?
There is, and then there's university studies as well that look into this that we can help. So, in the feasibility studies we've done with the Department of Defense, there's a degree of open data you can use.
Hmm.
But then you can work with institutions that really know how to assess the subsurface. And so we work with the Bureau of Economic Geology at the University of Texas.
Okay.
They have access as well to a lot of well logs, a lot of temperature data, seismic lines. They can go acquire seismic lines as well that already exist. If you're in an area with none of that, it becomes a little more challenging.
Sure.
But that's kind of when you think about where do you want to start developing, you want to start more in an area with kind of a confidence interval of data, right? And what you'll find in the geothermal resource. So where do you find that heat at the economic depths? We are greatly expanding the footprint of geothermal with what we're doing in next gen and hot dry rock geothermal, but it's still heavily weighted on the western half of the country. The
Sure.
rock in the eastern half, you just got to go deeper to get to the heat.
Okay.
So western half of the country is still kind of your areas. South Texas, North Louisiana, Gulf Coast has a degree of viability as well and some good potential. But when you start thinking east, you're really not going to be thinking eastern half of the country for geothermal power gen necessarily.
At least today, right?
At least today. So there's a lot of work ongoing on how do you drill deeper. There's a lot of technologies being developed to be able to go deeper, and that will be a game changer in this when those are developed.
Yeah.
What we're trying to do right now is where can we get the heat using off-the-shelf technology?
Absolutely. Yeah. You talk about off the shelf technology. What about, and this is the thing that landmen think of, what about off the shelf wells that have already been drilled? So are there scenarios where you can take a P&8 well or a well that's getting ready to be pulled offline and re-enter that well? Or is it kind of one of those things it's cheaper to just do it right the first time and drill your own wells? Is there a strategy there, or?
We get this question a lot.
Yeah.
Um,
Especially
and
people who are trying to dump a bunch of crappy wells.
if you think about repurposing wells, there's a lot of cases to want to do that, right? For geothermal power gen, it's going to be more straightforward, more economic to drill a new well. And there are a few reasons why oil and gas wells are not really conducive to geothermal power gen. One, a lot of them don't necessarily go deep enough to the temperatures.
Yeah.
Some do, but
Yeah.
not all. They tend to be smaller diameter. So in oil and gas production, manufacturing, been trying to drive down the size of the wellbore. And for geothermal, you need larger casing. So most oil and gas wells are typically not going to be large enough. And then, of course, you have the integrity issues of existing or old producing oil and gas wells. So you have to do a lot of analysis on the pipe and the well to see what kind of integrity does it have. Can it last another, 20, 30 years?
Yeah.
Plus for what we're trying to do with it. When you start to look at all those factors, it's going to be more straightforward just to drill new wells.
Yeah. That makes a lot of sense.
With that said, Sage's test well that we started working with in South Texas a few years ago when we first started is actually an old oil and gas exploration well. Because it's exploration, it was a larger pipe, so it was usable and it was
Yeah.
fit for purpose for what we were trying to do. But when you're
Relatively new
thinking
enough. And
long-term producing, you're not going to find that necessarily that attribute in a bunch of wells all close to each other per
yeah.
geothermal.
What does that casing size look like? So, when we does bigger casing equal better economics, more base load power generation? What's the equation there?
So power generation is determined partially by flow rate. So you need the bigger pipe to get the flow rates, to get the heat to surface at the rate you need to get utility scale power out of
Makes
that.
sense.
So you really need that larger flow rate without the friction losses in the system that smaller pipes can bring.
Okay, that makes sense. So, want to step back a little bit. We talked about earlier, one of the challenges with grid-oriented type energy projects is that interconnect and the queue. And you mentioned how placement of your projects is affected by that location. We talked about direct purchase agreements and things like that with data centers and so on and so forth. Let's maybe expand upon that. Obviously, everybody knows data centers is going to need a lot of power, and your system allows that kind of 24/7 base load potential to feed those systems. Beyond that, do you see geothermal being something that inevitably can scale to the point where it can provide constant, grid-based power? And if so, what does that look like? Is that a 15-year effort? Is it a 20-year effort?
Absolutely. So if you think, as I mentioned, conventional geothermal, such a small part of the current energy mix, just because it's so limited on where you're going to find it on the resource. The DOE did a liftoff report looking at next gen geothermal. So just to give you an idea of just how the size and the resource potential with this, 40 gigawatts of conventional geothermal potential, up to 5.5 terawatts of next gen geothermal potential. And that was the 130x increase. And that's per the DOE liftoff report. That gives you an idea of the size of the prize. And so as we continue to develop the system, as we continue to prove the commerciality of next gen geothermal and continue to demonstrate the scalability, clearly hyperscalers, data centers, that's a market, but you would expect to see this in many more areas as well. It's just part of the grid and a growing component of that grid.
That makes sense.
But let me just add to the kind of resource piece and the scalability and getting this into the power system as a consistent energy source. The scaling of geothermal power generation will be supported and enabled by the infrastructure, by the competency base that already exists in the oil and gas sector. So when I describe the technology to you, it's gonna much of it has come from that sector. When you describe the large project management skills needed to build these facilities, the contracts and procurement skills needed, the land skills needed, that comes from the oil and gas sector. And so this is very much a strong complement and natural bolt on to that sector. The service companies we're using are also being deployed in oil and gas. So the rig we used to drill our 3 megawatt storage well a few months ago, it was drilling an oil and gas well right before. And I saw it the other day, it's drilling an oil and gas well now.
Drill a well tomorrow.
This
Yeah.
fits in, right? We're not having to develop new competencies. We're not having to develop new service providers. We're generally not having to develop huge supply chains, particularly in the subsurface.
Sure.
And that's one of the big enablers that's going to allow this to really grow as we
Yeah.
continue to work through and develop the technology.